Okay, so for this question, the first thing we want to do is to write down everything we know. So initially, we know the demand, and we use D to denote the demand. And demand will be 10 per day. Since they are 310 days per year, so our demand will be equal to 3,100 per year. Then we know the product cost will be $5, and the holding cost will be 20% annually. So H will be 5 times 20%, which will be equal to 1. So the first question we want to answer will be, if the shop want to place an average of 20 replenishment order per year, what order quantity should it use? So in order to do the calculations, the first thing we want to do is to figure out how many days that we need to place a new order. So we know they are 310 days per year. If we want to place 20 orders per year, that means every 15.5 days, I need to place orders. Okay? Then I know my order quantity divided by my daily demand will be equal to 15.5 days, which means my order quantity in this case will be the daily demand 10 per day multiplied by 15.5 days, which is equal to 155. Okay? And for the second question, we want to know if the shop order the toys in quantity of 100, what is the implied fixed order cost? So for these questions, we assume that the optimal order quantity is 100. And before we do anything, let's write down the formulation for the EOQ model. We know Q star is equal to 2AD divided by H. So right now, we know order quantity is equal to 100. And this will be equal to 2 times AD. A will be equal to, let's see, that's what we want to calculate. And D will be 3100. Everything divided by H. So I know 10,000 should be equal to 6,200 times A. In other words, A will be equal to 10,000 divided by 6,200. If my calculation is correct, A will be equal to 1.61. So the setup cost will be 1.61. Let's try to work on problem C. And in the problem C, it said that if the shop estimates the cost of placing a purchase order to be $10, what's the optimal order quantity? So this one is pretty standard. We want to calculate Q, and so we know Q will be equal to 2 times A times D divided by H. And 2 times, in this case, A will be equal to 10. The third term will be 3100. H will be equal to 1, which means Q will be equal to 249. Okay? And for the very last questions, it said that if the supplier offered to sell the toy at $4.98 when the order size is greater than 500. What should the shop do? So in order to do these questions, we first need to figure out what will be the order quantities. And this is the extension from problem C. So we know without quantity discount, the order quantity will be 249. Okay. So what we can do now is to figure out what will be the profit when you order 249. So I know this is for product D. I know if I order 249, my profit will be equal to H times Q divided by 2 plus AD divided by Q plus C and D. Okay, and by plugging all the number, we know this is equal to 15748.998. Okay, remember for this one, we assume C is equal to 5. Then we want to know what will happen if the order quantity can be increased to the amount where we can get a discount price. So we know the quantity should be equal to 500. That's a minimum for us to receive the discount. So for Y, 500, HQ divided by 2 plus AD divided by Q plus CD. Okay, the C here will be 4.98. And if my calculation is correct, this one will be equal to 15750. Okay? So at this point, we can compare the cost for when we order 249 units and the cost when we order 500 units to see which one is lower. Clearly, this one is lower. So the optimal order quantity that we should do would be 249. Okay, so we don't want to order 500 in order to get a price discount.